Your brain and nervous system are made up of millions of tiny neurons, busily transmitting information between each other. However, most of these neurons do not touch another neuron. How is the transfer of information possible if the neurons do not touch? The answer lies in chemical particles called neurotransmitters. My name is Timothy Brown, and in this video I would like to have a look at neurotransmission. The neuron you can see on the screen is a multipolar neuron, which is the most common type of neuron in the human body. It has an axon and two or more dendrites extending from the soma. When a neuron is excited, a signal flows down one of the dendrites and into the soma. To be passed on, the signal must then be fired down the axon. However, if it's not strong enough, it won't be fired. When a neuron is excited at multiple places simultaneously, the combined signal may be strong enough to get fired down the axon. At the end of the axon are small sacs of membrane called vesicles, full of neurotransmitters. The signal causes these vesicles to burst, releasing the neurotransmitters into the synapse, which is where the neuron communicates with another cell, normally another neuron. The neurotransmitters can then bond with a receptor on the dendrite of the target neuron, allowing that neuron to receive the information being transmitted, and if necessary, to pass it on. Often we can find things in the visible realm that are similar to what happens at a cellular level. When a bird's nest fungus is ready to release its spores, it abruptly inverts its hull, sending its eggs flying into the air. The eggs then burst, sending spores flying in all directions, to begin new fungi, which in time release their own spores and start the cycle again. When the signal is fired down the axon, this is comparable to the egg being launched into the air. When the eggs burst, releasing their spores, this can be compared to the vesicles bursting and releasing the neurotransmitters. In both instances, the particles that are released find their destination and begin the cycle again. It is to these busy neurons and the neurotransmitter messengers that you owe your ability to think, feel, ow, and learn. Without these neurons and their neurotransmitters, your body's internal communication network would be drastically incomplete. Thank you for watching, and I hope all this talk of neurons hasn't made you nervous.